Digital infrared sensor. As we are all aware about, the IR sensor is a device which detects IR radiation falling on it. Like, there are the numerous types of IR sensors that are built and can be built depending upon the application. Proximity sensors used in touchscreen phones and edge avoidance robots, contrast sensors used in line following robots, and the obstruction counter sensor used for counting goods and in burglar alarms are some examples which use IR sensor. Before going ahead, let's see what is actually a digital sensor and why we are using the digital sensor. The digital data is expressed in terms of two discrete values. Either it is 0 or either it is 1. The smallest unit of digital data is called a bit. One bit of a digital data can only be one of two values, either 0 or 1. Unlike analog data, where one unit of analog data can be hold any value possible. So, apart from the analog, for example, like there is a toy car which is designed such that the remote control has only two buttons. Both of them will make the car move forward, one with a speed of 30 kilometers per hour and the other with 60 kilometers per hour. We see here we don't have an option to move the car at any other speed other than the ones defined above. There are only two discrete levels of speed. That is how digital data is in nature. Analog data can be converted into digital data using analog to digital converter. Our music CD players at home are nothing but highly sophisticated analog to digital converter, since they convert analog data on a CD to a digital data, process the data and amplify it. Reconverts the processed data to analog data and output the music via speakers. So in hardware, data information can be expressed as voltage, that is a 0 volt or a 5 volt. They are also known as digital logic. High means 1 for 5 volt and 0 for 0 volts. So if you want to make a digital sensor, we will have to use device which create discrete level and only give out 0 and 5 volt as output. These device in the design that we can using the LM358M, which is a dual operational amplifier. Any general purpose operation amplifier with similar gain and operating voltage can be used, like the LM324M, and we are using LM358M dual op amp, or you can say operational amplifier. So let's see what are the components and how do we make. Now let's see what do we need to make an digital sensor. So first and the basic component is a infrared LED. So infrared LED, all of you are aware about that, is a LED or a diode which emits the frequency in the IR range. Infrared radiation is invisible to human eye and hence we cannot see the IR LED emit it when it actually is. But there is a way to see IR radiation if you want to. If you look at the IR LED through a lens of a camera, suppose this is my IR LED and this is my camera. So when you see the IR LED through the camera screen, you can watch it properly. But directly our eyes cannot see the IR rays. So next we have a photodiode. So a photodiode is a type of diode which detects light. We can think of it as having a very high resistance when no light is falling on it. As we increase the intensity of light incident on it, the current through it gradually increases too. So by increasing the incident light on a photodiode, we convert it into a normal low value resistor which conducts current. We should note here that the photodiode looks exactly like a LED. So you can see here it exactly looks like an LED, sometimes with a dark blue or a black film on the outer casing. Next we have the op amp LM358M. So LM358M is a general purpose dual op amp or operational amplifier. Knowing the working of an operational amplifier here is really of no use to us, as we are not using it as an amplifier as such. So we will only be taking about how we use it here in the IR sensor circuit, what it does, but how much about how it does. So basically we use it to compare two voltage. One is fixed and the other varies with an environmental parameter. If the parameter control voltage is higher than the fixed voltage, then the IC should give one output, and if it is lower than the fixed voltage, then it should give another output. So we see the ICs gives only two types of output, which we designed to be 5 volt or 0 volt. This makes our sensor digital. That's why we are using the op-amp. Next we have our registers. So the variable register is a 3-pin register. Here you can see this is a 3-pin variable register, or you can say a potentiometer. In this circuit we use it to calibrate the IR sensor according to the environment. We give VCC and ground to the terminals which are close together and connect the center terminal to the threshold of the IC. So in this we are going to give the VCC and this one in the ground and this one to the IC LM358. Now let's see the schematic diagram of an digital IR sensor. So this is a Proteus layout of a digital IR sensor, in which here you can see we have connected the LM358, and here it is an IR LED, here it is a photodiode, which are connected through a resistor of 10k each, and here is our normal LED for giving and sensing the output. So and here is our potentiometer through which we can vary and adjust our data sensor as per the environment condition. So in this way you can make a schematic diagram and design your own digital sensor. So this is a 3D view of our digital sensor looks like. So this is, we are having a IR LED and this are photodiode. This one is LM358N. This is our preset. This is indication LED, and these are the connecting terminals, and these are the couple of resistors. So let's see about how does it work actually. We may hold the IR LED directly in front of the photodiode such that almost all the radiation emitted and reaches the photodiode. This creates an invisible line of IR radiation between the IR LED and the photodiode. Now if an opaque object is placed obstruction this line, the radiation will reach the photodiode and will get either reflected or absorbed by the obstruction object. This mechanism is used in object counter or burglar alarms. There are the two types of incidents. Either it is a direct incidence, means the light is directly falling on the photodiode, or a indirect incidence. Suppose in high school physics taught us that the black colors absorb all radiation and the color white reflect all radiation. We use this knowledge to build our IR sensor. If we place the IR LED and the photodiode side by side, like in this diagram here you can see the photodiode and IR LED are placed side by side close together, the radiation from the IR LED will get emitted straight into the direction to which the IR LED is pointing towards, and so is a photodiode, and hence there will be no incidence of the radiation on the photodiode. So in this way the reflecting surface is behaving. If it is black, suppose the reflecting surface is black, so IR frequency which is reflecting from the surface is not get reflected back because it is absorbed by the black surface. And if the surface is white, it is reflected by the white surface. So in this way the IR sensor actually works. If the object is reflective, either white or some other color light, then most of the radiation will get reflected by it and will get incident on the photodiode. Now let's see where do we use them. We can use them in, first of all, in robotics, in line follower robot. It's a kind of robot which follows a simple line. Here is our robot, so it follows this line and is having one IR sensor over here, or robots which are having two IR sensors like this, so they will just normally follow the line. Next is proximity sensor, which are used to detect the motion. Third is burglar alarms, or you can say anti-thief alarms, which are used in home security purpose. And the final is an item counter. This is a kind of counters we have in which we are using a IR sensor. So the moment when the object passes the LED, it just count. So in this way we can use the IR sensors. Next we are going to learn about the analog Infrared sensors.